everyone. I'm Lori Lynch from Blue Lake Union Elementary School District. I'm happy that you could join us here at Maker Night. I have two activities for you today, the first one of which is exploring pi. So here's a video explaining about pi and an activity to go with it. So I hope you enjoy. Hello everyone, welcome to Exploring Pi. I've decided to share this information with you during the month of March for Maker Night because 3/14, March 14th, is celebrated around the world as Pi Day. 3/14, March 14th also happens to be the birth date of one of the greatest mathematicians and physicists to ever grace this planet, Albert Einstein. So it's fun for a couple of reasons. If you are interested in pi and you wish to explore careers in math and science, you'll find pi in your careers of choice as you get older. And currently as a student, you'll come across pi in your math and science classes. So I thought we could explore pi in a fun way today, and let's get started. Pi in the real world. So pi is a real number that is irrational, which means it never has an exact final answer. It is an infinite decimal number, which means it goes on forever without stopping. So pi is 3.14, and then it goes on forever and ever and ever to infinity. It doesn't stop. Google and the people at Google, along with their computers, have computed pi to 31.4 trillion decimal places. So that's a lot of numbers to deal with when you're trying to do a math problem. So worldwide, globally, universally, scientists, mathematicians, teachers, students, we all understand and agree that pi's value should be about 3.14. in order to make calculations much easier. Pi is used to find the area and circumference of circles. So area is the space that is covered by an object. So if I were to trace a circle on a piece of paper, whatever's inside of that tracing line of that circle, that would be the area. And you find the area by taking 3.14, which is pi, and multiplying it by the radius, or r, squared, which means the radius would be any distance from the center of the circle in a straight line to the outside of the circle. So there's many different choices you can make for your radius measure. As long as you're going from the center, straight line, to the outside of your circle. So let's say your radius measure was 2 inches. So to figure out the area, you would take 2 inches and square it, which means multiplying it by itself another time. So 2 times 2 would be 4, and then you take 4 times 3.14, and you get the area of your circle in units squared. If our radius for our circle was a little bit larger and you had a 10-inch radius, you would take 10 times 10 to get 100, and then 100 times 3.14 to get your area in units squared. In this case, it would be inches squared. To find the circumference of a circle, circumference is the distance all the way around a circle from the starting point all the way around back to that same starting point. And circumference is found by taking pi, 3.14, and multiplying it by the diameter. The diameter is actually 2 radii. That means a radius plus a radius. So if my radius was 2, my diameter would be 2 plus 2, which is 4. If my radius was 10, my diameter would be 10 plus 10, which is 20. And you'd either take that 4-inch example or that 20-inch example for diameter, and you'd multiply it by 3.14 to get the circumference of those specific circles. So circumference is diameter, whatever your diameter is, the distance from the outside of the circle through the middle to the other side of the circle. That's your diameter. And you multiply it by 3.14 to get the circumference. Pi has uses in building and construction, quantum physics, communications, music theory, medical procedures, air travel, spaceflight, and graphic and digital design on computers. Pi can also be seen in circles that occur in nature. So, for example, if it's safe and comfortable to do so, if you go out to one of our beaches and you find a sand dollar, those are circular in shape. And I bet that you could explore that circle that you found in nature, that sand dollar, and see if it compares to other objects that you might use in this exploration of Pi. So here's what you will need for this project. You'll need yarn, which is in your kit, scissors, which hopefully you have somewhere in your house, invisible tape, which is also in the supply kit, and circular or cylindrical objects that are non-breakable. Please make sure that you get an adult's permission to use the scissors and any objects that you plan to measure. So here are some examples of things you could try. The lid off of the Pringles container is a circle. You could measure around that. Many of us, I bet, have some disinfecting wipes in our houses just because of coronavirus and other germs that we might come across. So you could measure the container top or bottom of those wipes. I found a roll of tape that is a circle shape. You could use a mug or a cup to measure around that circular top or bottom. I noticed that my container of salt was a cylinder, so the top and the bottom of that cylinder are a circle shape. For this particular example, a video I made for you related to this project, I used the Los Bagels cream cheese container lid. But I bet whatever you find, that'll be fun for you to try. All right, so let's start off by finding the diameter of our circular object with yarn. You're going to place your yarn across the center of your object to bisect the circle into two equal parts. In this case, you're going to have semicircles. So you'll notice in picture 1 that the top above the yarn is very close in size to the bottom area underneath the yarn. They're almost exactly identical, so that was a pretty good split through the center to find my diameter. Diameter is the measure of length from one side of the circle through the center to the other side. So that piece of yarn is representing our diameter. Image 2, though, that shows two parts, but you'll notice that they're not equal. The upper part is much smaller than the lower part below the yarn. So even though it's two parts, because they're not equal, that is not our diameter, and it would be an inaccurate measurement. And so we don't want to do what's in number 2. You want to try to get your diameter so it looks like what's in number 1. After you get that diameter measure, you're going to cut it, and then you're going to make two more copies of that diameter. So you're going to have 3 string diameter measurements in total.
Here is how you're going to use your diameter measures of yarn to go around the circumference of your circular object. So you're going to take your first piece and we're going to tape it to the edge. Anywhere on the edge is fine of your object. And it doesn't have to look perfect or pretty, it just has to be stuck on there. And then you're going to take your fingers and you're going to kind of run it along the side here with your yarn. And then tape that second end down. Now 1/3 of the outside, 1/3 of the circumference is covered by the yarn. You're going to take your second piece And another piece of tape. And we'll tape it down right next to where we ended the first one, trying not to overlap. Looks pretty good. Okay, and then run your fingers along again. Grab another piece of tape. And then repeat the process, just taping it down. All right. So now 2/3 of the circumference are covered. Now you're going to take your last piece, meeting up with where you just ended, taping it down. Okay, and then running it along the end here. And it's okay that it doesn't meet up with the first piece where you started, because you'll remember that pi is 3.14, and then it goes on and on and on as a decimal number forever till infinity. So this empty space here, it's supposed to be here because the 0.14 and so on, okay, all those decimals, place values after the decimal point, this is what it represents, this empty space here. So then you would measure with your yarn that little leftover space, and then you cut it, and you end up with this little tiny piece that would go right here. So that's why pi is 1, 2, 3.14. It's the diameter 3 times plus a little bit more around.
So you'll see, hopefully your results will show something similar to what my results did. Your circle might be a little bit larger or a little bit smaller, but you should have 3 diameter lengths plus a little bit more that make their way around the circumference of your circular object. 3 diameter measurements plus a tiny bit more make up the circumference of this one. So I want you to try your activity using your objects of choice to see if you get something similar to what I got here. So I hope you enjoyed exploring pi a little bit with me. You're welcome to show your friends, show your family, show your teachers. They'll be impressed by all the things you know about pi. I'd also like to share with you a couple of books related to my presentation today. One of them is about circumference and pi, but it's a fun picture book. So I'll be sharing that with you in just a moment. And then also I'd like to share a book with you about the life of Albert Einstein. So I'll show you those in just a moment, and I will leave the authors and the titles of those books so that you can access them, hopefully at our local library, or you can purchase them for yourself. I hope you've enjoyed this video and enjoy making and have fun. Thanks for joining me. So I hope you guys enjoyed that Exploring Pi activity. And as mentioned, I have the 2 books that I wanted to share with you. And hopefully on the website after this recording, you can find these resources or ways to get these resources. The first book is called Circumference and the Dragon of Pi, A Math Adventure. and it's by Cindy Neuschwander. And it's a picture book, but it has all the different ideas surrounding pi and circumference, but it's in a fun picture book sort of way. So I highly recommend that one to you. And then also, because 3/14 Pi Day is Mr. Albert Einstein's birthday, I have this book called On a Beam of Light. It's a story of Albert Einstein by Jennifer Byrne. So that's another really great picture book biography about Mr. Einstein's life. So now we're going to go into the second activity, which is the whirly twirly copter. So I have another video for you to enjoy regarding this activity. And I hope you enjoy. So here it is. Hello there, welcome to the Whirly Twirly Copter instructional video. This is an engineering exploration. So I'd like to give you some background, some of the science behind our fun. This project has to do with engineering, which is designing and building structures using scientific experimentation. This also has to do with aerodynamics because we're making something fly or float through the air. And aerodynamics is a study of how air moves around solid objects like moving vehicles, airplanes, or in this case, a paper whirly twirly copter. This exploration also has to do with gravity. Gravity is that force that pulls things toward the earth and to the earth. Flying things work to temporarily overcome gravity. This project also has to do with the idea of lift. And lift is what keeps something up in the air. Spinning propellers generate lift, in this case, slowing and controlling a fall to the ground. And then some real-world uses or careers that have to do with these ideas, and maybe this project will spark your interest in, are aerospace engineering, aircraft designing and mechanics, and even drone designing and operating. All these careers have to do with these scientific ideas. So they're worth exploring if you find this fun. So here's what you need for your project. You're going to need the Whirly Twirly Copter printout that was in your kit. You'll need a pair of scissors and tape or paper clips. You don't need them necessarily, but they're kind of fun to experiment with to see if it helps or hinders. So if it's a good thing or a bad thing for your copter to have on it. The tape and the paper clips are also in your supply kit. And you're going to need a high spot to drop your creation from. So you could drop it from a chair, you could drop it from the top of a table or a set of stairs. Make sure that you talk to an adult in your house and ask permission before you do that, because standing on chairs and tables or up on the second story, sometimes you just need to have supervision so that you're safe. All right, to construct your copter, what you need to do is you need to cut your template in a rectangle shape along the solid lines that are on the outside. And that's what these pictures show. Cut on solid black lines all the way around the template. Then you're going to need to cut the short lines between A and D and B and C. Be careful not to cut the dotted line section. So that's what these pictures show here. And you'll see there's a dotted line section here that we don't want to cut because that's going to help be part of the body of your copter. So don't cut any of the dotted lines, only the solid parts. Okay, then you're going to cut the solid line between D and E. Be careful not to cut beyond this dotted line. So you can cut right up to it, but try not to go over it because it will affect the structure of your helicopter. Next, you're going to fold A and B inward on the dotted lines, and then do a sharp crease and unfold it. Then fold C upwards on the dotted line. Do a sharp crease again, and then keep it there. With C still folded upward, fold A and B back inward. And you should end up with what this third picture looks like. And you see how it's loose here? That's why you might want to use tape or paper clips. And you can leave it open too and see how that affects its flight. That might be an interesting way to experiment. Okay, the next step, you're going to fold D towards you and E away from you. Tape or paper clip the bottom, which is optional, to hold the copter together better. Decorate your creation if you want. I didn't decorate mine, but I think it would look really cool spinning around if you put some color and some designs on it. That would look really neat. All right, I'm going to show you a brief little video of me dropping the copter from me standing on top of a table. And again, if you're going to stand on a chair or a table in your house, you have to ask a grown-up first for permission. All right, let's check it out. Let's watch it again, that's fun. All right, there we go. Okay, so have adult permission and supervision while standing on a chair or table, or you can have an adult do this part too, because sometimes they're taller, so it gives it extra height. Hold the copter with your arms straight up and release. Watch it spin. Maybe try dropping it from a high structure at a playground or from upstairs if you have that in your house or at your apartment building. And again, if you're at a public playground, just make sure that you're following all the safety guidelines, safety rules, making sure you sanitize your hands or wash your hands before you play, and make sure you stay 6 feet from others and wear a mask if needed if there's people around. Also, if you live in an apartment building, you might make sure that you're not disturbing any neighbors, just to be kind and polite. All right, we got one more slide here. All right, and I decided since I have a second story in my house, I was able to climb some stairs and drop it from a balcony, and I'd like to show you what that looks like. And again, you could replicate this from dropping it from a playground structure or a second story at your house or in an apartment building, but make sure to ask permission. So dropping from a greater height, let's check it out. Oh, that's so cool. It had a little bit more flight time. Let's try it one more time. So cool. All right. Well, I hope you have fun constructing your copter and making it fly, decorating it if you want. Thanks for joining us. If you need to watch this video again, feel free, share with your friends, share with your family, and enjoy your Maker Night. All right, guys. Thanks for watching. All right, guys, I hope you enjoyed Whirly Twirly Copter. I hope you found a fun place to fly those. I'm going to hand over our next presenter to you. Her name is Mrs. Z, and she is from Northern United Humboldt Charter School. So take it away, Mrs. Z.